Hello everyone, my name is Jacob Kugler and I am with Team 2 in EGR 368 with Jasper Bailey, Tanesh Daniels, and myself, and this is our short sword final project. The problem statement for this project is that we are tasked with creating a short sword out of scrap steel from the manufacturing shop as our project. This project was to combine our understanding of manufacturing processes as well as our knowledge when it comes to designing and manufacturing a product from scratch as well as fixture design. Introduction to this project. We are tasked to make a sword that contained the following four components: a blade and tang, guard, handle, and pommel. To start, we are given a 1/4 inch by 2 inch by 28 inch hot rolled steel stock for the blade and tang, and all of the initial design for the components were done in SolidWorks. For the project constraints and specifications, our blade was required to be 16 to 20 inches long. Our tang was required to be 5.5 to 6 inches long. The thickness was 0.25 inches max, as per the thickness of the scrap steel that was used for the blade and tang. The width was required to be 1.6 inches, and this was a limitation of the plasma cutter as well as the scrap material that was used. The center mass of the sword was to be 3 to 5 inches in front of the guard, and this is the desired center of mass for all short swords. The sword was modeled in SolidWorks into the four different components, and then drawings were created to make our final product too. For the rough cut of the blade and tang, the plasma cutter was used. To finish the plasma cutter form, we used the manual Bridgeport for all operations. Initially, we were using a fixture for the chamfers set at a 30-degree angle, and once we reached the end of the blade due to an excessive amount of chatter, we changed that over to clamping the part directly onto the table and mounting the head at a 30-degree angle. For the remainder of the pieces, we used solely the Bridgeport drill press or horizontal and vertical bandsaw. For the material selection of the blade and tang, we used hot rolled steel. This was from the scrap rack and provided to us at the beginning of the project. For the guard and the pommel, aluminum was taken from the scrap rack and then cut down to size using the horizontal bandsaw. For the handle, we used scrap wood, and that was provided by our teammate. For the manufacturing operations that we chose for this project, for the blade and tang, we started with the plasma cutter and we moved to the manual mill for the form operations, and then the pneumatic grinder to finish the form, sand and polish to get the material down to a smooth surface, and then we stoned the edge to achieve a sharp edge on the sword. For the guard, we used the horizontal saw and then proceeded to finish the operations on the manual mill. A sand and polish operation was also done at the end of both the guard and pommel manufacturing process to achieve a smooth finish at the end. The pommel was also cut off on the horizontal saw and then was finished on the manual mill. For the handle, the bandsaw was used, followed by the drill press to create the through hole for the blade and tang, and then a sanding finish was completed and then stained to achieve a attractive finished material condition. For the final product, we had a successful completion of the sword to our model specifications. The only modifications that we did to our initial design was that we eliminated the threaded hole for the pommel, as well as changed the singular hole in the blade to two holes for fixturing. The fixturing was achieved using two 1024 through bolts. Originally, the through bolts were set to a 1/4 20, but due to the angle that the plasma cutter put onto the part, we ended up switching this due to the undersized holes. As a, in conclusion, we had a successful completion of the sword, and we would recommend the use of more stable fixturing in the future, and this would have less required manual grinding at the and sanding in the final processes. For the plasma cutter, it achieved a near shape design, but the angle on the edge reduced the overall width dimension significantly to 1.45 inches. Along with this, we had to modify our fixture design to accommodate for the smaller holes on the blade. The sword was able to successfully cut through 2/3 of a watermelon and a complete banana, and this will be shown in our demo video.